Hey, welcome everyone, it is John the Net Guy, and today we're going to be doing a PC upgrade. Let me give you a backstory on this one. This PC was actually built in 2021 by me for my cousin's son. Speaking of GPUs, you'll notice that, well, this one doesn't have one. It is an AMD 3200G. It's got 16 gigs of RAM, only a 256 gig NVMe drive, and it's got the integrated graphics on this. Now, there is a 500 watt power supply in here, so that's going to be a benefit to us. There's also a 1 terabyte game drive. So I'm going to go through all of the steps here and everything that I did to make this a much faster gaming machine, and I'll take you along to that journey. So just in case you're in that same position where maybe you have a early budget gaming machine, maybe you have a GPU and you want to upgrade, I'm going to go through the process that I took and show you exactly the results when we upgrade this one. So first things first, he's a 12-year-old with unfettered internet access. We're going to need to do some cleaning of this PC, both inside and out, it looks like. Let's get started. I'm going to log right into it. Now, this is the offline version of Malware Bytes, and the reason I picked this specifically is I didn't want to have to plug it in to the internet and have it potentially infect my other network. So our first scan is complete, and as you see here, we've got this Wave potentially unwanted program. We have one launcher, potentially unwanted program, and plenty more, 416 in all. One thing I like doing is a BIOS update before we upgrade a CPU, especially to a newer generation CPU. Now, I just happen to be able to pick up this Ryzen 5500 CPU. It's a natural upgrade and evolution from the 3200G, especially because we're going to go to a dedicated GPU. When you have a dedicated GPU, you don't need the G ending CPUs that have the integrated graphics. So a 5600G and a 5500 are almost the same performance. They're still both PCI Express 3. That will be one limitation, but this one's going to be 6 cores and 12 threads, going up from his 4-core, 4-thread by nearly triple, and the performance is at least 60% better. Another thing that I'm noticing in the BIOS is that the memory timing does not have the 3200 mega transfers in the DOCP profile or XMP profile, as you'll see. So that's one of the things that we can turn on. I'm going to go into advanced mode, which is going to give us the tools to upgrade the BIOS. So we're going to go into Easy Flash 3, and then it's picking on our storage here, and there's our BIOS file. And yes, we want to upgrade to this version. So now we're flashing the BIOS to the very latest version, and it's also a testament to Asus that they've actually been releasing new BIOS and binary updates here. There we go. The BIOS update's been successfully completed, and we're going to restart the system. So now this is a great opportunity to do a benchmark of the system. I'm going to go ahead and install Passmark, which is going to be able to benchmark the entire system, graphics card, memory, CPU, and everything all at once. This is also a great opportunity to kind of do a mini load test against the machine, especially after we install our new parts. There are other load testing tools that we can run, and we may do that, but this is a great starting point here to give us a baseline of how the machine's performing before we do our upgrades. This is great because it tests the performance in Windows or Windows applications and what an office environment might use. So a lot of times I use this test when comparing for businesses what kind of systems and system performance we're looking at outside of gaming performance. So in this case, this is a 1080p test here. It's doing a simulator and it's running at about 35 FPS, which is not great. Again, it's showing the limitation on this for 3-dimensional graphics, especially anything that's going to have some sort of textures to move around, and it's right about the 30 FPS range. So we're going to see how much faster this is going to run when we upgrade the CPU, APU to a GPU. Now we're doing the DirectX 11. We're in the 17 to 20 FPS range, and as the complex scene gets even more complicated, I expect that to slow down even more, down to 15 FPS here. This is going to be a dramatic difference when we put the new GPU in. You can see it stuttering here. This is going to be a dramatic difference when we get to the new one. This is somewhere between 60 and 75 FPS to do the calculations here on this test. So these are doing sequential read and write testing, and then we're going to go to the IOPS and we're going to do small random reads and writes throughout the drive to see how it performs in both scenarios. Okay, the tests are complete. we're at the 39th percentile. That means out of 100 computers out there in the world, this one is ranked about 39th. Couple things to look at here specifically on the percentiles. The CPU is at the 41st percentile. The 2D graphics are doing a little bit better at the 50th percentile. The 3D graphics are pretty low there at the 32nd percentile. The memory's okay at the 53rd, but I think the CPU could actually increase that memory bandwidth a little bit. And the disk is doing okay at the 67th. We're gonna see how much we can increase these numbers with our targeted upgrades across the board. So the next benchmark I'm going to run is from Unigen. It's the Heaven benchmark. It's a little bit older, but it's still a really good test overall of graphic GPU performance. So already I can see it's getting about 20 to 25 FPS at this resolution. We're going to go ahead and run the full benchmark and let it go through. And now we have the results. 30 FPS is a great round number to start with here, and a score of 755. And now this is the superposition benchmark, also from Unigen. It's a great test of graphic performance. We're going to set it to 1080p medium, and we're going to go ahead and run it. Okay, and here we have the end results. 2053 was the overall score here, and you can see the current build setup. So next we're installing Cinebench R23. This is a really good test to test processing CPU performance, irregardless of GPU, memory, or disk. Yeah, single core Cinebench. It's really painful to watch this.
3,000 and 3 points.
And here are the single threaded core results. Looks like we have 894 as the result for single threaded performance. Okay, the test is finished. As you can see here, this NVMe, the 256 gig that's in here, very respectable numbers it put down. 3,500 megabytes per second read and 2,038 megabytes per second write. So those are pretty impressive. So this is the AMD 5500 CPU. It's a Ryzen 5 5000 series chip. He's going from the 3000 to the 5000. It's also a jump in performance with a 4.2 gigahertz boost clock. It's also going to have 19 megs of cache built in, and it's a great option for upgrading. One thing is though, it requires a discrete graphics card. There is no APU in this model. So unlike the one right now where he's doing the integrated graphics gaming, we're going to have to add a GPU as well. So we're going to go ahead and install this one. Now, for the graphics card for this system, I actually got a great deal. I was looking for an RTX 3060, but I actually ended up running across this RTX 2070 Super with almost no usage on it, if any, because it was an RMA return. So the customer had a problem with it in his pre-built machine. He was in the middle of COVID, and so they sent him out this one, and he honestly had already bought another one and replaced it and just had never used it. Because this chip doesn't have a built-in graphics engine or a graphics processor, we're gonna have to install a GPU. Now, luckily, our power supply includes the 2 necessary connectors for this one, and this one's gonna take an 8-pin and a 6-pin. So let's go ahead and install it. Now, this GPU has 8 gigs of video memory, which is a big upgrade, and will be plenty for your 1080p gaming. It should do amazingly well in most games. Now, as is with all of these PCI Express ones, they have a locking clip. So as you push them down, make sure that the back has fully seated and engaged, and then we're going to install the power. This time, make sure though that you're taking this connector and you're plugging it into the back here into the GPU and not back into the motherboard. That's one difference, is that you're going to have dedicated graphics now, so you don't need to do that. You can plug it right into the GPU. So for a hard drive upgrade today, he only has a 256 gig drive in this, and he's running out of space. They live in kind of a rural area, so as he downloads games, he has to either choose to delete the game or move it to the 1 terabyte spinning drive that they have, which is still not big enough for all the games he wants from Steam. So we're going to go ahead and install a 1 terabyte drive upgrade. Now, unfortunately, this motherboard only has 1 NVMe slot. So how do you upgrade from an existing NVMe without losing all your data? Well, this is an NVMe Caddy. So this is going to allow us to put this drive temporarily as a USB drive, copy all of our files over to it, and then swap them out into the single NVMe slot. very simply in here, because again, you don't have any other mounting needs. They all mount the same here. This is a 2280 drive, meaning 22 millimeters by 80 millimeters long. And this is a 1 terabyte form factor. I'm gonna use a piece of software to do the cloning, but there's many options out there and available. Now this has a very small screws on one end, and you can put it in the enclosure if you're gonna use it permanently. If you don't wanna use it in a permanent situation, you can take just this piece, very small screw out here, and we can use the drive in an open configuration like this. Just make sure it doesn't hit anything metal. Okay, now you can see that this drive is already almost completely full. It's showing my other USB drive, which is not big enough, so I'm gonna remove that. Okay, so the new drive already has partitions. We have to be super careful here, and it's gonna copy 230 gigabytes of data from the existing NVMe across the USB onto the new drive, and it'll have 75% of the space available. Okay, the cloning operation has completed, took just about 20 minutes here. We're gonna find out if it's successful. The next thing we wanna do is shut the machine down gracefully, and then we're gonna swap the NVMe drive. Now, I have enough room that I can actually reach down in here, and I can take the NVMe drive out. But if you don't, you could absolutely move the GPU unit if you want. So I'm gonna go ahead and take this screw out. These screws are really small and really easy to lose. I'll take that out. That's the old drive that actually performed fairly well. Make sure it's engaged, and then go ahead and put your screw. So there we go. Windows has already started to boot up, so everything's copied over. The bootloader's working right. The UEFI is all working and set up properly. We're gonna go right into the computer, and we've done most of the major upgrades. So here are the results from the final test of the 970 EVO Plus 1 terabyte drive that we upgraded to. As you can see, the write performance went way up, which is great. But overall, both were really good solid state drives. This one just happens to be better. So I'm looking forward to what the overall benchmark is now that we have all three components in. Let's go start that up. Now you remember we installed a new processor here with more threads. We installed a new GPU, and we installed a larger, faster hard drive. We also fixed the DOCP or XMP profile on the memory, but we also checked that beforehand. So I'm expecting the memory will be about the same, maybe a little better just for the benefit of a faster CPU, but we're gonna run all the tests now and see how it changed. So all of the CPU testing is done. Now I'm excited to see how the 2D and 3D graphics of this very nice GPU are gonna perform. So we're on to that. Yeah, the SVG performance, super smooth, much better. Now we're on to the 3D. Now, I know that the 3D performance here was about 30 to 35 FPS. We're over 270 FPS, now about 230, 250. Incredible jump, almost 10 times faster. Oh, now this is incredible. This one was one that had a whole bunch of struggle bus with, getting down to 10 frames a second, 15 frames. Now I'm seeing over 100. Up closer here, it's slowing down to about 70. But again, much faster, much smoother, actually playable if this were a game. Very good frame rates, over 100 FPS, 140 FPS now. It's doing really, really well. So obviously integrated graphics is nothing compared to discrete graphics, and this card is doing an incredible job. And that's another night and day difference here. Over 700 FPS in this instead of 75 FPS, so 10 times faster. Wow, so the results are in and they are incredible. We took this machine from the 39th percentile of all machines. That means out of 100 machines in the world, it would be 39th fastest, to the 87th percentile. So we've over doubled its ranking in the world. 2D graphics up, 3D graphics up, memory got even better. So incredible results. And now we're gonna go run the Heaven benchmark again and see how it improved. It's almost no contest here. The new graphics rendering is pulling over 250 frames a second, nearly 10 times faster than the integrated GPU, and this is going to make all of his games that much smoother. I hope this machine is going to last him several more years to come in popular gaming. Okay, the results are in, and it is an incredible improvement. We went from 30 frames per second to 276 frames per second average on this, the score to 6952. So nearly a 10x improvement in performance by adding a GPU to this machine, upgrading the CPU, and giving it a little bit faster disk. And another fantastic showing here, 18,278 on superposition is many times faster than the original. So now let's take a look at how Cinebench performs on this new chip. Those 12 threads are ripping it up here. So when you have multi-processing going on, not only on the old one did we only have 4 core, 4 physical threads, we only had 4 core, 4 hardware threads. In this one, we now have 6 hardware cores with 12 thread hyperthreading possible, and you can see it is chewing up the numbers. I expect this to be 2 to 3 times faster overall. And so far, the same exact CPU cooler is cooling this chip as was the last one. The AMD 5500 is a 65 watt TDP chip, just like the one we upgraded from, so there's going to be no increase in thermal load on this. In fact, just due to generational improvements, it should probably run even cooler. So in another dominating performance, the new AMD 5500 came out with an over 10,000 Cinebench R23 multi-core score, and the prior score of 894 single bench is about to go down because this one also has a faster single core speed.
So there you have it. We've actually completely revolutionized this machine. We've gone over 3 times faster on the CPU based on the Cinebench numbers, and we've gone almost 8 to 10 times faster on the GPU by adding a graphics card. We also put a faster NVMe drive that's 4 times larger in here as well. And I'm going to drop in a 4 terabyte spinning drive to replace the 1 terabyte that's in there right now, so he's going to have some more room for backing up games that he's not actively playing. So what do you think of those upgrades? Would you have done the same thing? Let me know in the comments what you would have changed about this build and where you would spend your money next. Thanks for watching. This has been John the Net Guy.